Today's video is all about part 2 of comparing Petrobond sand with coal dust sand. Now what I didn't show you in the last video, this is what Petrobond sand is made from. This is the powder, it is the binder, and most people on YouTube probably would never see that powder because they buy it ready mixed. But why is Petrobond so expensive? Well, for a start, that powder is very expensive. But if you buy it ready mixed, it's even more expensive. So this is what I was given when I purchased the Petrobond sand binder and the oil. It's a manual on how to use Petrobond binder, but also it has a troubleshooting section which shows you what goes wrong and how to fix it. So here we are on the first page of the manual for Petrobond, and I'll read a little bit out to you. It says the key to its success is the use of oil as the tempering agent instead of water. The excellent reducing atmosphere results in an exceptional finish. Well, what I'm going to do is an experiment to show you exactly how Petrobond works. But we'll read a little bit further where it says additionally water expands to 80 times its original volume when turning to steam. Well, that is so wrong, that figure. So I'll ask the viewers, how much does water expand to into steam? What's the exact figure? A little bit further down in the same page in the manual, here's a very good piece of information and advice. It says Petrobond sand contains oil instead of water and needs less, if any, venting. So for all those people who insist on vents when you're using Petrobond sand, here it says you don't really need them. So here we are in the troubleshooting section of the Petrobond manual, and it's interesting here to see where it says too much oil in the mix. When excessive amounts of oil are used in Petrobond mixes, the surface of the metal may show slight imperfections. This is exactly what happened to me in my previous video. The fact that the sand is only ever meant really for non-ferrous metals, and when you're pouring cast iron at higher temperatures, the fine sand combined with high oil will cause problems on the surface of the casting. After my last video where I used a very fresh batch of Petrobond sand, this sand here is one that's been used many times with aluminium and with bronze. As you can see, it's a very dark colour and a lot of the oil will be burnt out, and the reason why I'm using this one is this is the experimental pattern I'll be using. It is 17 millimeters thick, so what happens is that cast iron will stay liquid for quite a long time. So we'll sieve on the used Petrobond facing sand. Now what I want to do is I only want half, so I'll go across like that. And we'll clean this sand away. So I've got exactly half in there. This is freshly prepared backing sand. It's just bentonite and sand, no coal dust. And I'll sieve some on. Now the same deal for the top part of the pattern. This is facing sand, it's just bentonite and sand. Be covering the whole of the top of the pattern. The two mould halves have been separated, and what the idea of the experiment is that I push the Petrobond sand aside with a ruler. So I want a sharp demarcation line between the Petrobond sand and my backing sand. But what the foundry literature says and the Petrobond pamphlet is that when the Petrobond oil burns, it produces a reducing atmosphere. There's no oxygen in there, so what I want to find out is, with that reducing atmosphere, will it actually give a better finish on here because there's no oxygen in the mould, or what is going to happen? Is it going to be a sharp demarcation line across here and also on the top of the mould as well? There's no Petrobond sand on here, so if the reducing gas is around here, it should give a good finish on there, but we'll see what happens. This is the casting I poured into the sand mould, where half of it was Petrobond, the other half was new sand but no coal dust in it. And straight away I can see it's a far better finish with the Petrobond on that side with no coal dust on that side. It's very rough and the sand is sticking to it a lot more. And the same with the back. It's just a rough finish on there because there's no burning to lift up the metal. The test casting has been cleaned up with the wire brush, and this side here is the Petrobond side, and this is the side where there is no additive whatsoever. You have a look at that line, it's very distinct. Now the manual in the Petrobond book said it reduces at a reducing atmosphere, so if the metal's coming in here, why doesn't it make this side here, because the reducing atmosphere as well as here would be over here? It actually does not do a thing for this side, and you can see that. So what I'll do, I'll go and get a close-up, a real close-up view for you and show you the difference. So here is our close-up, and you look at the left-hand side. The surface is very rough, but the right-hand side is a lot smoother. That was with Petrobond. So what's actually happening is that the metal is being lifted up and it doesn't actually quite touch the sand, and it stays that way until it forms a hard face, and then it has a very smooth finish. As in my previous video, I'll be using coal dust sand again, but with this experiment we'll show exactly how coal dust gives a better finish on iron casting surfaces. But we'll have a look at this book, The Principles of Iron Founding. And this is a fairly old book. This is a 1930 edition. It's a second edition, originally printed in 1917. So we'll show you where the idea of using coal dust and how they say it works. So here we are on page 361 in the book, and we'll have a look at what's written down here. And it says two things can happen to such a facing sand. Either the gas formed may act as a film or as a layer just an instant before passing through the mould, but long enough to let the iron glide by without eating into the sand. That's one reason. Now I'll have to go over the page and look at the other one. This is the next page. It says the heat of the molten metal throws out carbon from the rich gases, therefore smoking the mould long enough to do the work desired. Such a carbon deposit will quickly disappear, being either taken up by the metal or else burnt away. The chances are that both things will happen. Well, that's what I'm going to find out. Is it one or the other, or will both work? Now this is the sand that's got coal dust mixed in with it. It's a dark colour, and what I've done, I've pushed it to one side, and we'll see exactly what happens. What usually happens is that coal dust burns and it lifts up the metal and gives a good finish. But what the books say is it also takes the oxygen out of the mould. So if it does, I'm going to sieve some plain sand with no coal dust in it. So if it does do it and burns the oxygen out of the mould, then this part here will have a good finish as well as that part there. This is my normal backing sand. Tends to go dark because it has a residual amount of coal dust in it, but also coal dust burns to coke. So what I've done, the back part of the mould just there is just white sand with bentonite. There's no coal dust in it. So if the coal dust does burn the oxygen out of the mould, it should give a nice clean finish on that as well. And there you can see the two halves of the mould. One side is coal dust, the other one is sand mixed with bentonite. No coal dust in it. So this is the same as the last test casting, like with Petrobond sand. This side where the coal dust is, the sand comes off reasonably easy, and this side here it is sticky, and you can see the line down there. It's quite obvious that something has been added to the sand. And if I flip it over, same thing again. The top side of the surface there is very rough. So if it produces a reducing atmosphere or a smoking atmosphere, so like the book said, it would cover all inside the mould there and give it a good finish. But it's a very sharp line there, shows that it does not. This is the casting that's been cleaned up. This side was no coal dust, this side was with coal dust. And as you can see, they still see the line down through there. Now what happens with coal dust is it's rated for different thicknesses of the metal in your mould. So this is a very thick one. I really do need to add more coal dust to give a slightly better finish on there. But because I'm casting mostly thin stuff, I use it for all of them. But really, if you go for thicker castings, you need more coal dust on that side. But what I'll do, we'll get a real good close-up of the sides there and see what they look like. So here is the close-up. You can see on the left-hand side, it's slightly smoother, and the right-hand side is rougher. And the reason why is because the coal burns, produces a gas and lifts up that metal and doesn't accentuate the peaks in between the grains of sand. It gives a smoother finish. But like I said, this sand does really need more coal dust to give a better finish. To finish up the video, decided to make a drawing, and this will explain a bit more detail about how Petrobond and coal dust works. This is the surface of a sand mould, and when the grains are packed together, you've got these little valleys all the way along here. Now what happens is, as the metal, this is the casting surface, it will fill in those little peaks, and when you run your hand across there, it will have a rough feel on it. But now when you put Petrobond or coal dust in the sand, what happens is it lifts the actual surface of the metal up. Not much, but it lifts it up. And what happens is you don't have those real sharp peaks. It's all smoothened out here and gives a lot more pleasing appearance. But also it separates, or the sand separates really easy from the casting. So what's the verdict? Can you use cast iron with Petrobond? Well, you certainly can. This test here, I was amazed just how smooth this is and how thick the casting is. And then you go to this side where there's no Petrobond, there's just plain sand. It's a very rough finish. But one thing with Petrobond, it's not cheap. So be prepared to pay quite a bit of money for it. But it works really well with cast iron.